Hello chemistry lovers, once again welcome to this channel of Muhammad Shahwaz, and today I will talk about organic radicals. Before making this video I was a little bit skeptical, but Shahnaz convinced me that I can also convey you some stories of organic chemistry, and I thank you for giving me this opportunity. Organic radicals, when I talk about, it might be stable, it might be unstable. In most of the cases it should be unstable. Why? Because radicals are reactive intermediates. Why they are reactive? Because let us take one example. So suppose this is methane, this is methyl radical. Okay, so if you draw methane like this, 1 2 3 4 5 6 7 8 octet, and if you draw this, you have radical here 1 2 3 4 5 6, and here you have another radical. So it is kind of, this is septate, right? 1 2 3 4 5 6 7 septate. So it, as you know, in accordance with the octet rule, the CH4 has much more stability than that of methyl radical, and so it will not be stable. Now stability can be attributed to a reactive radical system by means of kinetic stabilization or thermodynamic stabilization. Kinetic stabilization is often given to the system where the system requires inherent stability at instant. Because suppose you are doing some reactions and these reactions are very much rapid, so you don't get enough time to stabilize your radical species, or which is a reactive intermediate of your reaction, to confer thermodynamic stabilization. Then you have to look for kinetic stabilization. And how do you do that? So allow me to wipe out. Now when we talk about kinetic stabilization of any radical species, so kinetic stabilization may be of two types. You can put the steric bulk, that is steric, and another one is to increase the conjugation, pi conjugation. So I basically work on the pi conjugated systems, and this is my very much interest in the realm of organic radicals. So I thought it is worth sharing with you guys that how do we do in the practical cases. So kinetic stabilization can be attributed by steric bulk or pi conjugation. So for steric bulk, all of you are aware of this radical. This is some inoxide radical, right? And you put here steric bulk. Why? Just to stabilize this one. And another way of stabilizing radicals is pi conjugation. So suppose you have a pi conjugated system. It might be of many types, so I have given this flexibility that it might be looking like this. Suppose you generate anywhere an unpaired spin, and if it is delocalized throughout the system, then it is getting stabilized, because it does not get enough time to make any debris. So it might be of many types. So it is delocalized, so it doesn't get the time to react with some other species to degrade. In the similar manner, when you put the steric bulk, this steric bulk actually protects your unpaired spin from reacting with some other species that eventually lead to the degradation. So as the reaction with some other species leads to the degradation pathways, the steric bulk actually create the traffic jam so that it cannot react with the other species. So it is just blocking the pathway. This is basically kinetic stabilization. So let me wipe it again. So in this class I will not be talk about the nitty-gritty of organic radicals. Slowly we will encounter on that, but for the time being, let us take one very well-known example. I hope you know this Gomberg's radical. MD is sitting behind the lens, so I know that he also knows this very well, Gomberg's radical. So Gomberg's radical is, you have, I am writing in this way. So there is a common question in those who are doing this chemistry major. Okay, so here is a radical. So the question comes in this way. So this radical is stabilized to some extent. So they actually get stabilization further. They get further stabilization by dint of dimerization. So where to dimerize? They actually dimerize not from here, because these three phenyl rings are protecting this position. So how do they dimerize? They actually dimerize one para position of this one and another position of this one. They actually dimerize. So what you get actually, so you have this C double bond, so here you have radical and here you have two phenyls now, and now that is going to react this one and this one. So I am just erasing this out. So they actually now form the bond. So what is your structure now? So pH, right? So this is your structure. Now I will talk about the another way of stabilizing some alkyl radicals, which is basically known as hyperconjugation. You all know that. Now this hyperconjugation, you need some alpha hydrogen species. Okay, so alpha hydrogen if you have, then that is actually stabilized. So let us talk about some tertiary, let's say this one. Now as you know that homolytic cleavage of any homonuclear bond give you radicals, right? Now if you clearly see here you have a heteronuclear bond. This CH bond actually a heteronuclear bond. So how come there occurs homolytic cleavage of a heteronuclear bond. Heteronuclear bond should be cleaved heterolytically. So this is actually not homolytic cleavage, this is basically your mesolytic cleavage. Please do remember, this is mesolytic cleavage. Okay, so mesolytic cleavage, that is actually your mesolytic cleavage, and that actually gives you this radical. Okay, now how do they stabilize? They stabilize by dint of hyperconjugation. Hyperconjugation actually is sigma bond resonance, okay, or sigma conjugation. It's not pi conjugation. It is also known as Baker-Nathan effect. So how do they get the stability? So you know that you need some alpha hydrogens. So here you have basically 9 alpha hydrogens. Okay, so how do they get stabilized? Always remember, say hyperconjugation occurs via sigma pi or sigma p. In the textbook you will see the sigma pi or sigma p. P here is stand for this p orbital, okay, or pi orbital, any pi stands for. But I tell in a separate way, I tell sigma sigma pi or sigma sigma p. Why I am telling this, I will tell you. In the textbooks you will say either sigma pi or sigma p, but I tell sigma sigma p or sigma sigma pi. Why do I say that? Suppose let us break this one and extend it. Okay, now you consider this one. So mesolytic cleavage will do like this. So initially you had this one, this was a sigma bond, this is another sigma bond, and here you have an orbital. What kind of orbital it is? If it is planar, it should be a p orbital, and if it is non-planar, then it should be an sp3 orbital, because the initial geometry was, if you remember the initial geometry, so I give you a home task here. This is your sp3 carbon. So after this mesolytic cleavage, when it forms, what is the hybridization of this carbon? Okay, so what is the hybridization of this carbon? So if it is, I am giving you one hint, if it is planar, then it should be p orbital, because for being planar you must have the hybridization sp2. So one p is left, and if it is sp3, then it is sp3. So where this unpaired electron resides? Is it in p? So let me write the question. So I rub it off. So where this where the unpaired electron is it in sp3 or in p? Now if you see the orbital electronegativity, sp3 orbital has more s character than p orbital, more s character has more s character, so its orbital electronegativity is high, so it has a better ability to accommodate the pi electron, sorry, unpaired electron. But so the question is where the unpaired electron is. That is for you write into the comment section. So let us move further. So it is being stabilized by the sigma sigma p. So here is a sigma bond, another sigma bond, and this is your p orbital or sp2 orbital, that you need to tell which one it is. And last but not the least, I will finish shortly. These unpaired spin are being characterized by a popular method called EPR. Okay, this is your method for structural elucidation of paramagnetic species. Okay, and EPR we can discuss separately. I won't tell anything about EPR here. So this was the story of the organic radicals, and nowadays organic radicals have garnered significant research interest. Hope you have liked it, and I request you to like the video, comment it, share it, and subscribe to this channel if you haven't subscribed yet, and don't forget to press the bell icon. This pressing bell icon will help you of getting notification of any further video on this channel. Thank you.